This is something totally new, an ethical blockchain. Please, Johan, tell us more about this.
All right, with pleasure. So thanks for putting me in between the last slot and between you and pizza time. So I hope to keep you all awake. I'm trained as a university professor, trained to keep a few hundred students alive and awake after they had a beer drinking session at 9 o'clock in the morning. So I hope I manage now also. So I run the blockchain lab here, just a few minutes walking distance at Delft University. So I'm going to talk about the things we've been building over the past years. So one of the things what we've been doing is 9 years ago we put a system live when it was still called a distributed accounting system in the scientific terms. And now we would call that a blockchain, globally decentralized. So I created a blockchain lab. You see the URL in bold there. You can find all the real details here. So this talk will sort of prepare you a bit for this. So I will have graphs, but not too many formulas. So with a lot of esteemed colleagues with even more years of experience. So I've been doing trust building and self-organizing system for 17 years. And our stuff is now almost working. So this is how it all started. So I spent several summers at Harvard together making systems with them because I come from the Netherlands, and when we build a system, it's by definition legal. So that's always good. We're not that constrained as other universities. So here you can see the magical term. So this is a BBC News. We got several high things over the years. So one is bandwidth like a currency. So this is a few years before the Genesis block was mined in January 2009. And our system doesn't work that well. It doesn't have proper security, but it has unbounded scalability. So that's nice, since 2007. So we've been upgrading it, and this typical academic playground. So I just have people working for me for student credits, and I can give them PhDs. So we now have educated 5 PhDs in blockchain or proto-blockchain technologies at Delft. So our capacity is now 15 people per year who have a master level understanding of the blockchain. So if this keeps on going for a bit more, Delft will probably be the first serious university to do a master's degree in blockchain ledger technology. So just building on our existing distributed systems expertise. Oh, my font has gotten a bit smaller. I guess this is not running on a Linux computer. Nah. Right, so I've been working for more than 10 years on a sort of a European YouTube system with a BitTorrent engine in between. So ledger-based cooperative systems, so we've been internet deployed. This is our academic playground. So we had some nice installs, 1.8 million users infected now. So that's always nice. Open source, all this goodness, because I'm already paid by the taxpayer, so that's always good. URL, we run an open lab. So every meeting I have with my students, I make notes, and it goes public. They send me a draft of their thesis, I drag it also in there, and then everybody can just comment and see. So this is as public as it gets. So it's not, if there's no open meetings, no open voting, it's not a real open source project. This sort of like everybody can do pull requests in us. So this is open without compromises. So this has been running quite interesting chaos. We've been running for quite a while. So the first commit when we started actual systems was September 2005. I've been programming it since April 2005. That's at a bit of a time. So we kicked out a lot of code, but the current code base is 49 years of effort. So we had over 114 unique contributing code developers. So you can imagine it's quite a mess. The code base. So because a lot of people like to write code and contribute, but not clean up the unit test or get them running or improve the documentation. So the code is the documentation plus something like 55 master's theses and PhD theses. This is how it looks like now. We go on dark theme, so that's okay. That's yeah. I don't know why, but it happened. Yeah, so if you search for legal terms like Vodo, that's one of the Creative Commons brands. So you search for them, so that's why we have some various all non-copyrighted BitTorrent swarms coming up here. And that happens with sub-second speed. So this is sort of like the glue, the ecosystem where you can do ledgers in, your own ledger. That you need to have some people and some enticing thing. So how do we work together? Well, we have an overlay. So this is like a scalable version of Gnutella. So without the need for websites and all these things. So this is how it looks for the user, and this is their experience. So they can just do clicking. And this is the next step, is that these things will actually become thumbnails and will become a real YouTube. Why are we building a BitTorrent client at a university for more than 11 years? This is an unsolved problem since identified in 1968, that humanity has trouble working together. We don't always make peace. We don't make love. We don't give each other money. There's a wealth gap. We actually do nasty stuff to each other. We don't get along. We created the United Nations and all that stuff, but it's not all hugging and going together. So what we would like to do is for one resource, which is sort of easy, which is internet bandwidth, that without a central enforcing police force or an army or central bank or whatever, that we can actually play along and divide up that resource nicely. And now we call that a ledger, that we sort of contribute fairly, we give to the community and we take back from the community. Whoever donated blood in their life to the good cause, to the hospital or something, yeah, so the rest are just free riders. So these problems are real. So this is strategy of the commons identified by economists for a long time, and they give several Nobel Prizes for just describing it, not even solving it. So this is a hard problem. And that's actually what maybe the blockchain can solve. We don't know. We've been trying it for many years. And it needs to scale. That's why we brought out an unbounded scalable ledger in 2007. There's just a security problem, but we think we can solve that with repeated interaction and some proper nice crypto. Yeah, so some people in this room donate blood to the community, and then others can just free ride on that when you have bad stuff happens to you. And that's with a lot of resources, and we've been able to do a generic thing of this. One of the nice things, whoever uses Tor, whoever used that? See, Tor. The Tor privacy, hardcore privacy system. Who runs a Tor relay? Whoa, you're a special audience. Wait, was there another finger here? I saw, whoa. Yeah. So again, there's two people and the rest are just free riding. Right? But does the system work? Not really. Who uses Tor for their daily needs and have some proper privacy? Yeah, no, you can't have a proper internet experience if you're. It's not a proper system. They're doing great work, and we have. It's difficult to make these extremely difficult. Yeah, so why help others? And that's our use case, because the Darknet or an ethical Darknet, it's impossible to make. Nobody has ever done proper file sharing with proper speed. So Wikipedia, these are all things. So we would like a sort of a ledger or credit system or whatever. You can call it the Bitcoin, or you can call it whatever you want. There's now 4,000 altcoins in existence. But yeah, these systems need to actually work. So we have one of the only asset-based currencies, an internet bandwidth. So it's not a number of, literally a number of zeros that is worth something. Killer use case is proxies. So everybody has a VPN, or the two people who run Tor nodes. These cost a lot of bandwidth. You want to have, if you do some downloading or you do some privacy, you would like to be protected with a VPN. Or for performance, you would have multiple proxies and all nice, and this side is encrypted. That's all nice. But it's security, so more is always better. So we don't know what us scientists don't know what is good security. So we just pick the number 3, and then we encrypt in between. This is an open thing, and then you have a bit more privacy, but we don't know how good the privacy is. Then we actually don't only protect the downloader, but also the person giving you information, because if it's really information about nasty things, or other things in. So one of the things I tell my students that our technology needs to be Putin-proof. That's in these day and age, it should be more Trump-proof, but that's another story. So now you can do end-to-end encryption. So we have the full Tor stack implemented in a fully serverless way. So that should have unbounded scalability. This is the problem that keeps us driving. This is a concrete use case that would get a few million people or a billion people. You have proper privacy. That all these people in the middle need to actually donate bandwidth. So 1 gigabyte of actual privacy is a network load. There's only 2 people who are non-free riding on these sort of systems like Tor. 13 gigabyte of donations by the community. Nobody's going to donate. This is never going to work unless there would be a magical called the ledger and everybody just is forced to contribute to the community, otherwise they're locked out. So how do you do these systems? This is what we've been trying for a few thousand years. What you do is you do a gossip system. That is how we exclude people from a community who are too free riding too much. This naming and shaming or same. So in the pre-industrial revolution, when you did not know who made your bread, in the pre-industrial, you know the person who made your bread and who collaborated and who was free riding on the community, this hunter-gatherer, and they never help. You just exclude them from the community. So community size was bounded to 100 people, and there's some fascinating people who work on this. Then you have the McDonald's brand. You don't know what the food is, but you sort of know what it is. For some definition of, right? It's just calories, yeah. Exactly. And then you have all these brands and things that sort of to represent a certain thing, because there was now becoming a disconnect between the person who is actually doing something, making with your food or your services, and what you could understand as good stuff or bad stuff. You bombard them. Now, when you're drunk at 3 o'clock at night, you just do something magical with your pad and and stuff floats to the air, and then somebody stops in front of you and you just open the door and you hop in. Why are you getting into somebody who doesn't have a taxi driver's license with an organization that is structurally violating laws and has offices raided? And why are you doing these sort of things? Yeah, why? Oh, because it's money. Yeah, this is good. It's better money. It's a cheaper experience, but we try. So why do we trust these things? Because it has a 4-star or 5-star rating in an app. So it has the ability through central control to sort of create trust. You just open up your house, the Airbnb logo, and you just put 20% again to the platform. So the center takes 20%, and then sort of you just let wild strangers sleep in your house. Okay, that gives you money. Well, that is because there are no 3-star drivers in Uber. They get automatically fired by the computer. Really. So what we want to do is what you need to do is a scalable system, because credits, that's like the real world. The value of a country, of a currency, that's determined by its reputation and how good the central bank is. If there's a southern country in control, the northern country... No, I shouldn't do politics here. Generic reputation system. This is your credit rating. What we do at the university is we don't try to reinvent things. We try to see existing paradigms and reinforce them. So what we did is just this gossip system. Everybody can talk and lie and cheat and these things, but it has unbounded scalability. So it's just a ledger for bandwidth exchanges, and it actually sort of worked. Unbounded scalability, incentive compatible, blah, blah, blah. No global consensus. Come on, it's pathetic stuff from 2007. But the notation I will be using is, so node 1 is telling node 2, has done 40 services or 40 units or 40 bandwidth credits or 40 euros or satoshis, and you do voluntary reporting. Because we can't even get that to sort of technical work and things, so it's just no security, just let volunteers, just like Wikipedia, just throw it in there and see how abusive it gets. So that's Harvard, Delft, Berkeley work. Finally got published. This takes a few years to be accepted. First, the buzzwords need to pick up and stuff. So we're not bitter about that. So here you see sort of how this gossip works. You have the join operation. This is now the knowledge at node 4 of voluntary reports, and it has a graph representation of who owes what to the community. Who has given, who has done good deeds. This can be unit of bloods, this can be Tor relays, and then you can see sort of who's free riding or not. 3 also has a local database of reports on good and bad or good behavior and who receives service and given to the community. And then there's a decentralized gossip. It's just what we've been doing for more than documentedly doing for 2,000 years. The gossip. Who's a good person who has good community standing, who's contributing, who's leeching, and who's done things. And then together, 3 and 4 merge their representations and they see you need to have some identity, the same namespace, and all these fascinating things which are difficult, but you just map it and you have a growing graph, continuously growing graph. You can also throw stuff of the graph away. That's actually the key to unbounded scalability. If you just have a few gigabytes of a chain, which is a linear chain, that will never work for proper stuff. So that's very first generation technology. Sorry, that was a big insult there. So the graph representation, especially graph mathematics, that has a firm grounding and some proper nerds who understand that. So that's a very good, rough theoretical understanding. And it sort of actually worked. Here you see the deployment graph from many years ago of this ledger, just voluntary reports. This was just people who were downloading interesting content in BitTorrent and then reporting about how many bytes they gave to each other. So we can move beyond the tit-for-tat incentive, which is still the state of the art in these things, and we do not have a good scalable indirect reciprocity mechanism or credit accounting or decentralized ledger that actually scales. So what we've done added to this is a bit improvement to this. And now we can improve on this a bit further, that we have transaction modeling. And so we've done this 2007 stuff, and it didn't crash and burn too much. So Tor coins, this is Lira, Gold Star Par, and all these things. So everybody, there's various proposals on this, but nobody ever actually got this stuff to work. So it almost barely works in our lab, but it's getting there. So if you have transaction like this, let me see, where am I now? Very good. You can model this as A gives to B 10 units. C gives to A, so A takes 35 units from the community, and A gives to D 25 units. Then you have inter-thing arithmetic. So you have a bit of calculus, a bit of calculations here, that you have these transactions, you add them up, you can see sort of a balance. So this is just simple. If you can put transactions on a graph, now we add some fancy stuff. So you have the hash of this. So this technology from 30 years ago, you add this to that A and B and C and A. So you just do an append-only primitive. And but what is now the magic? And this is what Delft does, and that's the unbounded scalability burden. It's not a native cybercurrency. You cannot give money away. You need, it's a transaction approval system. After that, they become irrefutable. So that's a stronger primitive to build upon, but it requires 2 signatures. Both A and B agree that this transaction is taking place. So you cannot just freely receive money. It doesn't work like that. You have 2 people who do this, and then it becomes a transaction on the graph. So this is where you can do quite a boost in transaction processing, as we have done now with our code. You can do any asset. So this is a generic transaction processing fabric. And then you do some fancy stuff. And what you now see here, so you have tamper-proof recording of transaction, because both parties agree append-only, draft structure, all this fancy stuff we have now. But what we've done actually is in our current implementation is instead of a single worldwide chain or something, or one of these things, you actually use the graph mathematics and you have the fast mixing property. So you don't need a central entity, and you actually can prevent. So there's now talk of sharding in various communities, but this actually is just a locality principle, what we know from computer science. It's more generic than sharding. So what you have is you have A and B, they have a transaction, A and E after that, and A and G, and A and F. So, and then B has a transaction with A, and it has its own chain. So here's B again. So everybody has their own Genesis block. That's actually what you can then do. And then you can actually just vary the locality. How many people do you want to know the blocks of? So you can do that with a generic function. That's a little bit more flexible, we hope. But we'll see how all this stuff works out. Right, so this works nicely because I have students, so we don't accept any theory or stuff without working code. That's always the nice thing, if you can set your own terms in academia. So we don't do simulation or all that stuff. Running code, that's the only way to get your graduation on in our lab. So this one now runs 18,000 transactions per second without any optimization. Python code with some nice packaging and all this. So interpreted Python code running on this phone. Yeah, that takes a few students to get this normal Android phones to run this stuff. And then you still have this sort of performance. This is one of the first things that you have repeated interactions with Tor relaying, because circuits get refreshed every 10 seconds, and then you do the same people and blah, blah, blah. Anyways, it works. Other stuff we're currently improving in the lab. Oh, this is not a very nice. Random walks and all these things, so you can do this exploring. So this is also what did PageRank, and then doing this in a distributed way. Then you have some very firm grounding, and then you can actually understand this random sampling and can make strong assumptions on Sybil attacks and Eclipse attack. The most ferocious, you prevent that better. So this is all another PhD thing, which is finished now. Yeah, so the growing because people like consensus. This is a bit if it's a thing without consensus in it. So one of the things is instead of a thing where you have global consensus in a distributed system, that's known to be very, very expensive. And without a global clock, we know from the impossibility results from 1986 that it's actually impossible. So you need to put some boundaries there on the symmetry, asymmetry, time, clock stuff, whatever. What we do here is a stream that you actually find people who agree with you. And you just exponentially grow that, and we don't know where it will end. Then you're not vulnerable to the 51% attack. So, but you want to have awareness for various nastiness built into that. Maybe it will actually get some nice proof in this. It's difficult stuff. This is not running yet. This is design work. Final slide. This is it. If you like this stuff, we run an open lab, so you can see all the ongoing work. You can click on these people who are currently making this work, and you can see their work in progress and their code, and all the various things. So one of the key things I hope to have live next year is a fully decentralized marketplace. We have now a prototype with a bid and ask. So in 2014 we had an operational system which no scalability and no security. Now we have scalability and no security this year. So next year we hope to actually have some proper security in there with self-reinforcing trust mechanism. That's another few people working on that. Thank you.
Thank you, Johan. Can you tell me maybe a bit of? Can you tell us how can teams already use it if they would like, or can they play with it at a hackathon?
Yeah, sure. To have a thorough understanding of the fabric and being actually able to make sensible contribution to it, it takes roughly 1 or 2 months of full-time understanding of the technology. So this is not simple stuff. But the documentation, the dispersey read the docs, tribal read the docs, so you can get a sense of this stuff there. But just if you look at the Bitcoin source code, that's also not easy. So we have some of the higher principles all documented in these probably more than 1,000 pages of thesis documentation.
Okay.
So
Okay, right. So, and I was wondering, do you see this as a private blockchain or staying it that way, or should it go towards a public blockchain like Bitcoin and Ethereum?
No, this is all open lab, so there's nobody in control. Everybody has their own block, Genesis block. It's permissionless, so it's all open. It's a keyword search algorithm. So everything is open and paid for. Let me just quickly go back. What happens underneath? So what you see is you meet thousands of people on this overlay, and then you also sync with their blockchain and things. And there's no permission. You just see who's a good person and who's a bad person. That's all the things. We're also hoping to link this to our spam prevention and all these things. So it's permissionless. And everybody can just see these blocks, and everybody can also just push their own fake blocks or just their fantasy or that's the Sybil attack region, can just push that to the network. So one of the key things is because it's an open blockchain with unbounded scalability, then you have the spam problem with others because we don't constrain the transaction rate. So you need to, and that's also what's now already talk on the sharding thing, that you need to have some sort of locality principle or things, otherwise you get sucked into, you fill up your disk space. It's just a denial of service attack.
Okay, and can you also maybe tell a little bit about some of the projects you're already working on with companies? Because, for instance, we've learned that you're also involved in a consortium working on logistics processes. I think it's very nice to see that most companies that are also eager to learn more in what they can do with blockchain are also in talks with you, with your lab. Can you tell us a bit about that?
Yeah, so we have a nice, a few million euro contract with various, 16 companies, which I'm leading that consortium. So we do all some nice use cases. So we're currently creating another few million euro blockchain project, a nice consortium, and then we get over $1 million funding and subsidies, and we just run our subsidies with the government or university. So, and then we hire people and make them even smarter. So that's just our business cycle, and. So these are 16 companies who actually have problems and money, thankfully. So that's why I always like to be friends with them. So like the harbor of Rotterdam, a very nice, the biggest port in Europe, that they also want to be on the blockchain. And thank you also. Where's And Exact Software, this building is also thankfully in this consortium, and so that's very nice that I ask people, hey, do you want to be in the consortium, and do you want to just give us some money, and so they always say yes. So that's we love that as the university. We've never seen anything. This my entire building has never seen anything as crazy as the blockchain thing.
Oh, that's promising.
On one thing, we know we can deliver stuff. It's going to take a few years and stuff, and the whole public versus private needs to just clearly. It's never going to. These open standards are not forming. There's no ITF group yet, and the ITF that you have open voting. So all these foundations and this governance and future proofing it. That's all. But it's fun. We're probably going to make it.
So and Delft is also known for a great startup incubator. Yes, Delft. Would you expect startups to spin out of this blockchain lab you have?
Yeah, so when I still did file sharing, then we had a few startups also coming from my lab, and so had the building, was it 1 or 2 buildings? Yeah, so that's a steady stream of this stuff. But it's, so I expect several startups. But the business climate for that, it may be a bit difficult, because doing actual use cases, usually requires that you get sucked into this big IT system stuff, and it's still very difficult. I find myself handling complexity with blockchain apps. It's like if we had the previous speaker and all this business and contracts, and that's still very very difficult. We have now. Over the past years, we built 1.5 million lines of code, and what we did is just a silly file sharing client that actually works. So this complexity, let alone the tax office or proper apps. Well, you've done some work in Groningen. You know the realities of code, and so we'll see. Okay. Any questions from the audience before we start?
pizza. Can we get the cube over here? Yeah.
Does it work? Yes.
Yeah.
With the graph where you had node A and B, if you have the currency for bandwidth, if one lives in the TU Delft and has built up quite a bit of goodwill and then moves to Africa, is there, you will be very wealthy regarding that, I guess. Do you have a solution for that?
That's a fascinating example. No, the short answer is no. You have a certain value and a certain contribution to the community, and then the principle is that if you have given to the community, you should be able, people will jump you and help you back because then they can earn more. But this is actually an economic system that actually you not only need to manage supply, but also demand. It's very interesting that you can also have oversupply in your economy. That's what we already observed in the lab, which is difficult.
All right.
Right.
Thank you.
I saw one more question at the back.
Oh, yeah.
Almost. You focus on bandwidth, but if you look at storage, do you know Swarm?
Oh, yeah. No, we can do all sorts of stuff, and that will keep me another 10 years busy. And we haven't solved it. So storage is also a very interesting one, but because what we like to do is instead of work against market leaders, we actually try to steal their ideas and improve on them and just make it more powerful. So because BitTorrent is already filling the internet pipes, we just use the existing swarm paradigm. Because it's very difficult for normal consumers to just buy storage or something. That's not something they do. They just do a lot of BitTorrent stuff. So that's why it aligns nicely, and we get 1.8 million infections with our software.
All right. So, final question. I think we're ready for some pizza. Johan, thank you very much.